Moving on, Galileo, page 38. So, we could do a whole course on Galileo, but we'll just do a few things here. So, number one, he was the first to use a telescope for astronomy. He discovered the moons of Jupiter. Three, discovered the phases of Venus. Four, okay, so he was the first to use a telescope for astronomy. He discovered the moons of Jupiter, discovered the phases of Venus, discovered the craters and mountains on the moon, sunspots on the sun, and was the prime author of the scientific method. And okay, a lot of stuff. Okay, so like I said, we're in the 1600s. So this is now Renaissance is in full bloom. Who was Galileo? Well, he was really quite an accomplished academic, scientist, mathematician. He was right up there in society. He was the chairman of the math department at one of the major universities in Italy. It's not uncommon to see Galileo depicted in either TV shows or movies as this kind of benign, grandfatherly type. Well, no, he was anything but. He was really quite an arrogant SOB. He rubbed a lot of people the wrong way, but he got away with it because he was Galileo. First to use the telescope for astronomy. Now, it's a common misconception that Galileo invented the telescope. No, he did not invent the telescope. He built his own telescope, made several of them as a matter of fact, but he didn't invent them. So who actually did invent them? Well, historians are still kind of arm wrestling over that one. There are like 3 or 4 individuals that they've kind of zeroed in on. I don't think we'll ever really truly know. First to use the telescope for astronomy. Well, was he the first guy who got tired of looking through Mrs. Gilhooly's window at night to see what was going on? To see maybe what the moon is doing? Probably not. But this goes to what I've mentioned before. This is something that science and law enforcement, first responders, military, medical personnel, we all have this in common, and it's this: if it ain't on paper, it didn't happen. And so Galileo put it on paper, so yeah, he gets the credit. So what's going on here? Well, Galileo is well aware of the work of Copernicus. Like I said, the book wasn't banned. He read what Copernicus had to say, and it makes perfect sense to him. But now we have technology that did not exist in the time of Copernicus, the telescope. Technology is the game changer here. He thinks that with this telescope, he can get tangible evidence to support the Copernican hypothesis. This is where we get into this idea of scientific method. Now, Aristotle, we could say that he was the father of scientific reasoning. Oh, okay, fine. But that's a start, but it's not complete. The scientific method is arguably one of the greatest inventions ever. It's an intellectual protocol by which we do this thing called science, and we use it to this very day. The scientific method is a self-adapting, self-correcting intellectual protocol by which we do this thing called science. Now, it's important to understand the distinction between science and the scientific method. Science fails all the time. Science is 99% failure and 1% success, and that's on a good day. But the scientific method itself does not fail. Why? Because it's self-correcting. All right? And it's how we deal with the failures as much as the successes, perhaps even more so. And as we move along, we'll see that failures in science are oftentimes even more instructive than successes in science. But that's for another discussion. So, if you were to start your astronomical observations, what would be the first thing that you'd look at? Well, the moon, probably, and that's what he did. Now, it's important to pause here and look at where we are culturally at this point. So Galileo, as I say, is a big mover and shaker in upper society at the time. He's having his weekend drinky poo cocktail parties with all sorts of folks whose first names are Duke and Prince and Bishop and Cardinal. This is who he's hanging around with. Okay, he says that he's going to pursue this. He says that he's going to use this new technology to prove Copernicus right. And he's warned right from the get-go by folks from the church, be really, really careful with this one. You know, that could get dangerous. Yeah, says Galileo. He's arrogant, remember. So, the first thing he looks at is the moon, which would be obvious. At this point, the heavens, and this is why we call they are called the heavens for a reason. They are regarded as God's creation and therefore perfect. And this goes back to even Copernicus, because Copernicus believed that orbits were absolute perfect circles, but they're not. But we'll get to that in a minute. But this idea of perfection, of God's creation being perfect, was what played very predominantly here. And so the moon was considered to be a perfect, flawless sphere. Now, I know that you know that there are craters and mountains on the moon. Yeah, that's true. But you can't see them with the naked eye. You really can't. Get a pair of binoculars and yeah, you can see them, but they don't. Up to this point, we don't even have that. So Galileo takes a look at the moon with his telescope, And what's he see? Craters and mountains. The thing's all beat to hell. Or as we say here in Maine, it's all stove up. It's all rutted up. So that certainly isn't a perfect sphere. Now let me talk about Galileo's telescope just a little bit. It's not like one of these jobbies here. This is a pretty nice rig. And we'll talk about this here when we talk about Sir Isaac Newton. Galileo's telescope was this long thing, about so long. Think of the cardboard tubes that Christmas wrapping comes on. It was about like that with a lens at either end. Now, by way of a little sea story, when I was about 10, 11, 12 years old, getting my own nerd game on, my dad, who worked at General Electric, was walking by the lab one day, and a guy was coming out with this box full of lenses. My dad says, "What you got there?" He says, "Oh, these lenses here, we can't use them anymore." "Well, what you going to do?" "Well, we're going to throw them out." And my dad said, "Oh, like hell, give them to me. I'll take them home for the kid." And so that's what he did. He came home and I had this box full of lenses. And I took some cardboard tubes, and these lenses were absolutely, surprisingly, a perfect fit for either end of these tubes. And I made my own telescope. What do you know? The damn thing worked. Okay? But it was a very primitive type of telescope. Even though it magnified, it had a very narrow field of vision. But nevertheless, Galileo could do some amazing work. And you'll see some examples of that in other pages in your book, as well as on the website as well. So he did these detailed maps of the moon, showing just how beat to hell the moon really is. He discovered sunspots on the sun. What? What's that all about? Well, another misconception. Galileo went blind looking at the sun. No, he did not. Well, how do you look at the sun with a telescope? Well, you aim a telescope at the sun. Yeah, that's true. But instead of sticking your eyeball on the eyepiece, you take a piece of paper and put it where about 6, 7 inches away from the eyepiece, and it will project an image just like a movie projector. And that way you can see what the sun looks like, and it works beautifully. And so Galileo looks at this image of the sun, and he sees these dark spots. Oh, hell, it's got zits. The sun's got the worst case of acne. What's he looking at? He's seeing sunspots. Okay, so that certainly isn't perfect. That's not a perfect sphere. It too is very flawed. Then he looks at the Milky Way, which up to that point, to the naked eye, looks like a glowing cloud. But if you look at the Milky Way with even a pair of binoculars, you will see suddenly thousands of stars that were not visible otherwise. Why? Because a telescope has higher resolution than the human eye. It's like a digital camera. The more pixels you have, the higher the resolution. Well, the lens of a telescope, the light gathering lens at the other end from the eyepiece, that's called the objective lens. And its purpose is to gather as many photons on its surface as possible. The bigger the area, the more photons you're going to gather. The more photons you gather, the higher the resolution. The higher the resolution, the more stars you're going to see when you look at something like the Milky Way. So now he's seeing countless stars that weren't even imagined to have existed. He sees that. Nevertheless, when he looks at those stars, they're still pinpoints. And even if you took one of this little modern telescope here, even with this little telescope, if you looked at a star with that telescope, you would still see a pinpoint. Why? Because they are so far away. Remember, the nearest star to us is 4.2 light years away. That means that all the other stars are even further away. And it's just the sheer distance that keeps them from being able to be magnified enough to actually see a disk. They're just too damn far away. But then something else happens. Galileo takes a look at planet Jupiter. And instead of seeing a pinpoint, he sees this little tiny disk. It actually has a shape. And yeah, if you have one of these little telescopes, you will see that too. Jupiter is out in the western sky at night now. Okay. Not only does he see that disk, he sees these little dots in a straight line. And the next night he goes out and looks, and the dots have moved. And they keep moving. Like so. Well, what's he seeing? Well, he's seeing the moons of Jupiter. He's seeing that Jupiter has its own set of moons. And this is important too, because doctrine says that everything in the universe orbits the Earth. Galileo is looking directly at 4 objects what ain't orbiting the Earth. They're orbiting something else. He is the first human He is the first human to directly observe orbits. He knows what he's seeing. That's why they're called the Galilean moons. Callisto, Io, Ganymede, and Europa. Then, he takes a look at Venus. Now, this will take me a minute to get set up. So here's Earth. Here's Venus. Here's the Sun. All right, now this is a very simplified description of this, but it will suffice. So, here's Earth, here's the Sun, and Venus does orbit inside the Earth's orbit. So here's Galileo on planet Earth with his telescope looking at Venus, we'll say here. Now the Sun is shining on this side of Venus. That means that this side is dark. So that means that from Galileo's perspective, what's he going to see? He's going to see this. Just a crescent. A couple months later, Venus is up here. Here's Galileo on Earth. Venus is here. What does Galileo see? Well, he sees more just because of the relative positions. He sees that it looks like a half moon now. But it's smaller. Well, that would make sense because it's further away. A few months go by. Venus is up here. And Galileo seeing is almost but not quite a full Venus. Venus goes around the Sun, comes out the other side. And now Galileo sees something like this. Venus comes around here. Now it's starting to get bigger. And then finally Venus is here, getting pretty close to the Earth. And Galileo sees this. Now this becomes just a simple matter of geometry. The only way that this can happen is if this is how the Sun and the Earth and Venus are arranged. It won't work in Ptolemy's model. This will not work in Ptolemy's model. Up to this point, Ptolemy's model was just as comprehensive as the Copernican model. The prime attraction of the Copernican model was its simplicity, Occam's razor. But now Galileo has tangible evidence. And so compelling is this evidence that, again, I can't emphasize this part enough. This will not work in Ptolemy's model. It won't work. So this throws Ptolemy's model right out because it goes right to a fundamental feature of the model, that is geo or Earth-centric system. This will not work in an Earth-centric system. The only way this will work is in a Sun-centered system. So Galileo says, okay, I got it. I'm ready to publish. And he tells folks that he's going to do this, and he's warned by the Vatican. He is told, okay, go ahead and publish, but what you're going to have to do when you present this is you're going to have to do it this way. You're going to have to present it, wait for this one, fair and balanced. Which is to say, he is required by the Church to present on equal footing an Earth-centered system compared to a Sun-centered system. Galileo says, sure, I can do that. And this is where you get a little bit too smart for your own good. My old man used to call it being too smart for one, but not quite smart enough for two. So this is what Galileo does. You would think that he would publish some type of a scholarly paper or maybe even a very serious textbook. No. What he does is he publishes a pamphlet, about the size of this DVD case. And in it is a story, a short story, a fictional short story with 3 characters, 2 of which are debating heliocentrism versus geocentrism. And the 3rd character is a neutral moderator. He dedicates this little tome to one of the local dukes or princes, and that causes some ruckus. But he doesn't stop there. The character that he has advocating the Earth-centered system, he names him Simplico, simpleton. And as you read through the thing, as it gets toward the end, the neutral moderator says to the guy advocating the Sun-centered system, well, your arguments are compelling. It can't be any other way. And he turns to Simplico and says, you're an idiot. So yeah, this causes some ruckus, but he's still able to kind of get away with it at this point. But Galileo just doesn't know when to quit. What he does then is he takes it upon himself to start reinterpreting Scripture itself to accommodate this geocentric idea. Now recall, I said earlier that the idea of geocentrism fits beautifully in any number of Scripture. And so that's why it became, it became church doctrine, this idea of geocentrism. Well, now Galileo says he's going to reinterpret Scripture so that it now fits heliocentrism, sun-centered system. This is when, that's a bridge too far. And so Galileo has the singular distinction of literally pissing off the Pope. He did. And it's fortunate in a way that the Pope was, he's the newly installed Pope, and he was one of Galileo's associates prior to that point. But nevertheless, it's a bridge too far, so he is ordered to come in for tribunal. And this is where it almost becomes, it's almost like something out of the Godfather movie. He got sent for, and Galileo says, I ain't coming. And he's told, yeah, you are. And Galileo says, you know who I am? And they say, yeah, you know who we are? And this goes back and forth and back and forth. And by this time, Galileo's in his 60s. He's in poor health. But finally he realizes, yeah, he better show up. So he does. And brings his telescopes with him. And they start going through this tribunal. And this drags on for months. Months. And Galileo, to be fair about it, Galileo says, look, I will set up my telescopes and show you what I've discovered so that you can see it with your own eyes. And the response was, no, not even going to look. Not even going to look. So both sides have got their heels dug in. Neither side is budging. At this point, there are conflicting reports. Some say this happened and some say it didn't happen. But there are some reports out there that suggest that the church got fed up with him. And don't forget, this is the time of the Inquisition. They got pretty much fed up and they said, okay, they took him into a room and showed him the type of devices they were thinking about using on him. Nice stuff. If you've ever seen the movie Braveheart, you get to the very end. Yeah, well, Braveheart is the cleaned up kiddie version of what they really did to people back then. So Galileo, being smart, realizes it's time for me to back down. And so he does. And so he recants. Galileo recants. And the legend is, he did recant. That is true. And the legend is that as he was recanting, my bad, as he was recanting, he was heard to mutter under his breath, still it moves. I'd like to think he did. So there's Galileo. All right, we'll pause here and we'll get on to some other folks.